Assalamualaikum and greetings to Madam Amalina. Today my friends and I would like to present about vector applications in engineering. Before that, I would like to introduce the group mates. My name is Sufiyya binti BAHARULLIZAM and my matrix number is 01DTK23F1060.
Hi, I'm Balqis. My matrix number is 01DTK23F1059.
Hello, my name is Madam Amalina. My matrix number is 01DTK23F1080.
SHAARANGIN Jayshankar. So my matrix number is 01DTK23F1076. See you.
So I'm going to start with our presentation. So what is vectors quantities? Vector quantities are physical entities that possesses both magnitudes and directions. These quantities are represented by arrows where the length signifies the magnitude and the arrowhead indicates the direction. Examples include velocity, force, accelerations, and displacement in physics. So they follow specific rules of additions and subtractions, considering both their size and orientation, making them distinct from scalar quantities which only have magnitude. So this is the easiest way to remember vector. So we draw a vector from an initial point or origin called the tail of a vector to the end of the terminal point called the head of a vector, marked by an arrowhead. Magnitude is the length of a vector and it is always a positive scalar quantities.
And now I'm going to move on with our presentation, which is the application of vector in engineering, specifically in electrical engineering. So in the realm of electrical engineering, vectors serve as indispensable tools that streamline the analysis and comprehension of intricate circuits. Vectors are frequently used to represent alternating current AC quantities. So AC voltage and current are described by magnitude, phase, and frequency, which can be conveniently expressed as vectors. This representation is essential in analyzing and designing electrical circuits, especially in systems with multiple components and varying phase. In control systems, vectors are employed to represent signals in the frequency domain. This is crucial for stability analysis and designing control systems that respond effectively to various input signals. Additionally, vector analysis is used in magnetic fields to understand and design devices like transformers and electric motors.
Other examples of the usage of vector quantities in engineering in constructions. Consider the stadium is our example. So the stadium's roof is held by a series of cables arranged around the building's perimeter. Engineers use statics to determine how much forces, for example magnitude, each cable carries to hold up the weight of the roof along with the additional forces caused by factors like wind and or snow. Knowing the magnitude of force in the cable allows engineers to determine how large the cables need to be prevent from snapping. So cables are strong in tension, for example pulling forces, by a very weak in compressions, for example pushing force. So engineers need to not only know the magnitude of force but also which direction they act. Using equilibrium concepts, engineers balance tension forces with compression forces. In stadium plays, diagonal struts are designed to carry compression forces induced by tension in the cable, for example arising from Newton's third law. The struts needs to be considerably larger than the cables because long members that carry compression forces are sensitive to buckling.
Right now, I would like to explain about how to find magnitude and a unit vector. So magnitude, before you do that, you have to apply the formula, that is square root of x squared, y squared and z squared. So you have to know that so that you can apply it to find the magnitude of the vector. I didn't insert it in the presentation, but so you have to know it. At the same time, if you want to find the unit of vector, you have to take the x-axis over the magnitude plus the y-axis over the magnitude, so that you can get the unit vector. You have to, if it states plus means you have to plus it, if it states minus, you have to minus it. So that's all from me. You can look at the solution in the presentation right now. So that's all from me. Thank you.
So for the conclusion, vectors enables engineers to comprehensively analyze and design a construction, considering the multitude of forces acting upon it, ultimately ensuring its safety, stability, and functionality. For the first one, vectors can be used as foundational representation. Vectors are fundamental in engineering, serving as a precise and structured way to represent quantities such as forces, velocities, and acceleration in a mathematical framework. For the second one, versatile modeling tool. Engineers utilize vectors to model and analyze complex systems, enabling a deeper understanding of how structures and materials behave under varying conditions. For the third one, engineering advancements. The precision and versatility of vectors empower engineers to create innovative, safer, and technologically advanced solutions, driving progress and breakthrough in engineering practice.
So this is our end of the presentation. I'm the pirate guy if you are looking in the screen. If you have any question, please do drop it on the comment section down below. Thank you for watching, and please don't forget to subscribe and like it. And don't forget to share it.